In this video, we're going to take a look at our enemy design infrastructure. In our game, we have 3 enemies: Moss Giant, a Skeleton, and a Spider. What do these 3 enemies have in common? Each enemy is going to have its own speed, its own health, their own gems that they'll drop upon death, as well as an attack method. Now, what do you notice that I've done here? We have 3 individual classes with 3 implementations of the exact same data. It's a little redundant, don't you think? Imagine we had 50 enemies. That means that we're writing the same data over and over again 50 times. What if there was a way to where we could have this Moss Giant, the Skeleton, and the Spider take all of their common attributes and share them in one parent class? This is where what's known as class inheritance comes in. We have this enemy class that's going to say, hey, if you're an enemy, you have all of these predefined properties, such as int, speed, speed, health, gems, and attack. By having an enemy class that takes these core values, we can then say to, hey, Moss Giant, Skeleton, Spider, you're going to inherit the enemy class. And because you're inheriting the enemy class, you automatically get these core traits. Now, what we've done is if we have 50 enemies, we wrote the implementation details one time, and each enemy is going to inherit those values. The enemy scripts are still their own individual behaviors, so they can still write their own custom code, but we no longer have to write their core values over and over again. We wrote it one time, and each enemy is going to share that data. So this is called class inheritance. Now, we're going to be working with something called an abstract class. And an abstract class is going to allow us to set predefined definitions and kind of use our enemy class as sort of a guideline for an enemy so that we can ensure the proper implementation details are in each of our enemies. And we'll get into more of an abstract class when we start actually implementing this. The next thing we need to look at here is damaging. When our player is damaging anything in our game, when he swings the sword, how do we call the damage function on our enemy? Well, we have to first get a reference to the Moss Giant and call its damage function. If we attack the Skeleton, we have to get a reference to the Skeleton script, call its damage function. Same goes for the Spider. You have to get a reference, you need using get component on the Spider, and then get the damage method and call it. Now, imagine you had 50 enemies. Again, the player would need to access each of those 50 enemies by basically filtering through which enemy it hit and then grabbing that component and calling the damage function. Can you imagine how long that script would be if you had 50 enemies? Well, one way to solve this problem would be to add a damage function to our enemy class. So now all enemies have a damage method. And now what we can do is instead of searching for 50 individual enemies, we can search for just the enemy component. And the enemy component is just going to have a damage method. The player will no longer care which enemy it hit. It just knows, hey, I hit an enemy. It doesn't know which one, but it knows it hit an enemy, and it will know that, hey, enemies have a damage method. So it will call enemy.damage, and no matter which enemy you attacked, it will call its damage function and behave accordingly. Now, that's all fine and dandy, but what happens when we get into things like other objects that the player can hit, such as the chest and the box? Well, we're going to have the same issue here. What if we have 50 different items that the player can destroy with his sword? The same issue is going to occur. We then have to filter out which object you hit, get a reference to that object, and then call the damage function on that individual object. So how can we resolve this? Does it make sense to make another abstract class that defines an object? Not necessarily. But what we could do is introduce what's known as an interface. An interface is basically a contract that says to an object, hey, you must implement this method. So we would call this, for instance, iDamageable, and it's going to have a damage method. And what we would say to each of our enemies is you must implement this interface. So the Moss Giant, the Skeleton, and the Spider are going to implement the iDamageable interface. If we had 50 enemies, each enemy will implement the iDamageable interface. This will allow our player to swing its sword, not care what it hit, but detect that it has an iDamageable interface and call the damage function on whatever it hit. The same goes for if you have a chest or a box in your game. We will implement the iDamageable interface to anything that we can destroy in the game, and the player will no longer care what it is that it's hitting. It will just know, hey, you have this interface, I'm going to call your damage method. And then what's going to happen is the individual behavior of the chest, the box, the Moss Giant, the Skeleton, and the Spider will implement its own damage function and handle the function accordingly. What we're doing here is essentially removing all know-how from the player. the player doesn't need to know or care what it's attacking. If it detects that it has a damageable interface, then the script that it hit is going to handle how it's damaged, and our player is going to be very modular. All of the functionality is going to be isolated within its own script. That way, we have no dependency on any other scripts. Our player doesn't need to have a reference to 500 items, and we can just simply look for this damageable interface. Now, if you're not following along completely, it's totally okay. I will be going over these concepts individually as we implement them, and hopefully you'll get a better understanding. So without further ado, let's get started.